Students, let's start with rapid revision of metal and non-metal. Elements are divided into four categories: metals, non-metals, metalloids, and noble metals. So how we know that these are metals? Metals have the property of donating electrons. So metals donate electron and they have 1, 2, 3 electrons in their outermost orbit. Coming to non-metals, they accept electrons. Their electron acceptors have 5, 6, 7 electrons in their outermost orbit. Metalloids are that category which have both the properties of metals and non-metals. And noble gases or the noble metals, generally we call them noble gas. They have completely outer orbit. That is, their outer orbit is filled with 8 electrons. Let's start out with quick revision of physical properties of metals and non-metals. We comparatively study both at a time. So let's start out with the first property, which is called malleability. Metals can be beaten into thin sheet. Malleability is a property where they can be beaten into thin sheet. So metals are malleable in nature. Exceptional metals are beaten into thin sheet, whereas the non-metals, they cannot be formed into sheet. Ductility, they can be drawn into wire. Metals can be drawn into wire. Now exceptional cases are mercury and zinc. They cannot be drawn into wire. Non-metals, they cannot be made wire or they are non-ductile. Hardness, metals are hard in nature except lithium, sodium and potassium, which can be easily cut with knife. Coming to non-metals, diamond is the hardest non-metal. It is the allotrope of carbon, which is hardest metal. Sonorous, it is the property where producing sound, like metals are sonorous in nature. On striking, they produce sound. Exceptional cases, mercury. Lustrous, all metals are lustrous in nature, that is, they are shiny. Non-metals, generally they are non-lustrous, they don't have any shine, but there is an exceptional case, that is iodine and graphite, which are lustrous in nature. Electric conductivity, metals are good conductor. Best conductor is silver, but because of its cost, we don't make electric wires with silver. Generally, electric wires are made up of copper. Non-metals, they are poor conductor, but graphite is the good conductor, which is allotrope of carbon, which is used in electric cells or batteries. Now, heat conductivity. Metals are good conductor of heat. When they kept at high temperature, they get heated. Poor conductor of electricity, poor conductor of heat are mercury and lead, whereas the best conductor of heat are silver and copper. Melting point and boiling point. Metals have high melting point and boiling point, but gallium and cesium, they are the exceptional case which have low melting point. They melt on palm. They have such a low melting point that they melt on palm. Diamond is the only non-metal which has highest melting and boiling point. Now the next property, that is density. Metals have high density and non-metals have low density, but there is an exceptional case, hydrogen and nitrogen. State, metals are solid in nature except mercury, which is liquid in nature. And non-metals, they present in all the three states, solid, liquid and gas. Most probably all of you know, like liquid non-metal, which is barium. And then some are gaseous in nature, some are solid in nature. Liquid only, barium is the non-metal which is liquid in nature. Now let's start with the chemical properties. Chemical properties of metal. Metal react with oxygen to form metal oxides, and metal oxides are generally basic in nature. This is a very important point you need to remember. Metallic oxides are basic in nature. There are some metallic oxides which are amphoteric in nature, like aluminium and zinc. This example is very important for your exam point of view. Aluminium and zinc, when it react with oxygen, it forms oxides which show both acidic and basic behavior. They react with both acid and base to form salt and water. Like aluminium oxide, it is reacting with HCl to form AlCl3, that is salt and water. In the same way, it is reacting with base NaOH to form NaAlO2, which is sodium aluminate, which is salt and water. So thus, as it is reacting with both acid and base and showing acidic and basic both the property, we call it as amphoteric oxide. Generally, metallic oxides are basic in nature. Few example is there which are amphoteric in nature. Most metal oxides are insoluble in water, but some dissolve in water. When they dissolve in water, they called alkali. When metallic oxide dissolve in water, they called alkali. Now Na2O react with water to form NaOH, as aqueous is written here. Means it is in water form, that is in liquid form, it is dissolved form in water. So this is how they react with the oxygen. But all metals do not react equally with oxygen. Now the reactivity is different from metal to metal. So let's start out with how metals react with oxygen. So for that we need to remember activity series. So I wrote a sentence with which you can easily remember activity series. So all of you please memorize the sentence. Popular scientist can make a zoo in less humid country more satisfactorily. So popular, from P we can write potassium, scientist, S sodium, can calcium, make magnesium, A aluminium, zoo, zinc, in iron, less lead, humid hydrogen, country copper, more mercury, satisfactory silver, gold. So depending on reactivity we can easily memorize how the metals are reacting with oxygen. Highly reactive metal like sodium and potassium, they catches fire if they kept open in air. So that's why they kept immersed in kerosene. Again it can be one more question. Why sodium or potassium is kept immersed in kerosene? As they are highly reactive, so they catches fire with air. Now calcium, magnesium, aluminium and zinc, when they kept open in air, they covered with thin layer of oxide which prevent further oxidation. So as they are covered with oxygen layer which prevents it from further oxidation. So later on I'll explain what is this process called. Now iron, it does not burn on heating. So generally metal react with oxygen. Reaction with oxygen is nothing but burning. Iron does not burn on heating, but iron fillings burns vigorously when sprinkled on fire. Iron fillings burns vigorously when sprinkled on fire. Now copper, it does not burn, but hot metal is coated with black color layer of copper to oxide. So this also we need to remember how copper react with oxygen. So copper is reacting with oxygen to form copper to oxide. Rest of the two metals like silver and gold, they do not react with oxygen at all. Now as I told you, I'll explain you how this metals are reacting with oxygen and they are forming a coating that we call anodizing. So this is a process of forming a thick oxide layer of aluminum oxide which prevent further oxidation of aluminium with water, with oxygen. So here generally when we purchase any aluminium utensils, we find that they are very shiny in nature in the beginning, but after a few days or after few use, they get darken in color. That is, they covered with, if a vessel is there, it got covered with aluminium oxide, which is preventing it from further oxidation with oxygen. So once it will get a standard color, there is no more oxidation. So this is how the metals are reacting with oxygen. In my next video, I will upload about reaction of metal with water. So please follow it.